This was a former radar station back in the Cold War. This purpose of this facility was to scour the skies for any enemy planes coming over the channel. 100 feet underground. We've invested millions of pounds in power infrastructure, cooling and internet connectivity to really create one of the most secure data centers in the country. So we'll walk you through now and we'll take a look round. So now we're on the first level. I'd like to sort of talk you through some of the physical attributes this facility has. So the external walls are 3 meters thick, the internal walls are 1 meter thick, and in between those walls there's a rubber strip. And basically the design of the building was to be able to withstand a 22 kiloton thermonuclear blast. So that rubber strip was effectively absorbed the impact, so the inner walls remained stable. So this area here, we lower the customer's equipment down on the 5-ton hoist, and then this area will be where we would distribute the customer's equipment to the desired location within the data center. Just to get to this point alone, you've gone through multiple access control systems, and you've passed around 6 or 7 CCTV cameras. So here we have our internal 5-ton blast door that essentially protects the inner perimeter of our data center. So this is the opening to our Faraday cage. So this was actually designed to prevent any electromagnetic pulse if there was ever to be a nuclear blast that went off. But this also prevents any electronic eavesdropping. So all of our customers' data resides inside this Faraday cage. So now we find ourselves on one of our many data halls. So we've got standard hot and cold aisle segregation. And I want to talk you through really the fire suppression and the fire detection systems we have in place whilst on the data floors. So if you can take a look at the fire trace system in the back of the rack, this essentially localises any fire if there was to ever be a fire on this data floor, and it's unlike any other typical data flooding systems that you find. We've also got a fire detection system which is Vestas. Basically these got built-in holes into the pipes positioned above our aircon units. It's got a vacuum inside the system, and it's drawing the air in all the time, analysing the particles, analysing the temperature of the air. The minute there's a slight change in any of those sequences, it would detect a problem, and then it would identify that there's obviously an issue that we need to resolve. So now you find ourselves in one of our uninterrupted power supply rooms, which is fed from multiple diverse grid feeds. This essentially is battery-backed, filtered, smooth power, providing power to all of our equipment. So I mentioned earlier in the video that the external walls were 3 meters thick. We're at the 100-foot mark underground, and I just wanted to give you a visual representation of that. This was known as the inspection hatch. So you can see that they had a 3 meter thick concrete block, but in the middle was the rubber strip that absorbed the impact if we ever was to be under attack. So I've shown you the core infrastructure inside the data center. We're now outside, and I thought it'd be nice to follow on our conversations from the power infrastructure we were discussing earlier on. So the 2 incoming power feeds from separate parts of the national grid feed our UPSs. That is then backed by this N+1 generation system. So we have 21,000 litres of fuel on site, and these generators themselves have enough horsepower to run 250 family cars or a small village, just to give you a sense of scale. So there has to be a catastrophic event that happens in the UK national grid for us to lose power, but these systems essentially would keep all of our customers and all of our equipment online. So this was a recent upgrade to our facility, and these systems are in place as a simple backup to our equipment and our customers' servers. So to give them the peace of mind that in the event of a disaster on the national grid, they are still covered and always on.